What we're going to do is start Module 7.2 today. So if you don't mind, please follow along with the lesson, and we will go over this as I'll teach this as if I was teaching you in class. But yeah, just follow along with the notes, take them down, and then we will have time to start our homework. So let's see, I think it was like page 8 or 9 or so. So it's 9. A little further, actually. Here we go. 7.2 warm-up. So today's lesson, what we're going to be doing is looking at combining functions. And we're going to do that by looking at these two people practicing their running. So we have Fernando and Mariah, and they are training for 6 weeks to run in America's finest cities half marathon. To train, they run laps around the track at Eastland High School. Since their schedules do not allow them to run together during the week, they each keep a record of the total number of laps they run throughout the week and then always train together on Saturday morning. The following are representations of how each person kept track of the total number of laps that they ran throughout the week plus the number of laps they ran on Saturday. So here's Fernando. Fernando's data is represented with at 0, 60, 10, 66, 20, 72, 30, 78, 40 minutes, it's 84 laps, so on and so forth. So what this is illustrating is Monday through Friday, he ran 60 laps. So then when he arrives on the track to run with Mariah, he's already run 60 laps. Then him and Mariah run together, and every 10 minutes he's running an additional 60 laps. So as you can see right here, he ran an additional 6 laps. Here he ran an additional 6 laps. Here he ran an additional 6 laps. Mariah, on the other hand, when she shows up to run, she has only ran 40 laps. And then she continues to run together. So let's go ahead. I'm actually going to graph really quickly Fernando's data. So he will start off at 60, and then at 50 minutes he ran 90, which is a little too high. So at, let's see, 20, here we go, at 10 additional minutes it was 66. 20 it was 72, which is right here. So let me go and plot that really quickly. And here we go. So as you can see, we have two parallel lines. So what observations can be made with the similarities and difference with the two trainers? Well, let's talk with the similarities. That would be on Saturday, they run together, so they have the same rate of change. The big difference is Fernando ran more during the week, so he started off with 60 laps ran, while Mariah ran 40 laps during the week. All right, so then it says write an equation for Mariah. Well, they're running together, so their slopes would be the same. So then when we look at this, change in y over change in x, this would be 6 over 10, which reduces to 3 over 5. So that is their rate of change. So Mariah's distance as a function of time would equal, she runs 3 laps every 5 minutes, which is represented with the t, times the amount of time she's ran, plus the 40 laps that she ran during the week. So this will represent her total laps at the end of Saturday. Then Fernando and Martha both said they ran the same rate during the week. They are training separately. Explain in words how Fernando's equation is similar to Mariah's. Use the sentence frame. The rate of both runners is the same throughout the week. However, Fernando he ran more. He ran 60 laps. So Fernando ran for longer amount of time. And that makes sense. So if he's running throughout for a longer amount of time, but he runs at the same rate, that will make up for the extra amount of laps. So in mathematics, this is when we start combining functions. Sometimes one function can be used to build another. Write Fernando's equation, f of t, by starting with Mariah's equation, m of t. So if we remember up above, m of t is equal to 3/5 t plus the 40 laps she ran. Well, the difference between Mariah and Fernando is those 20 laps. So if we take Mariah's function, Mariah's distance, and we add 20 to it, that will give us Fernando. Remember, Mariah already ran, it already includes her slope, so 3 laps every 5 minutes times the amount of time plus the 40 laps. And Fernando ran the same as that, he just ran a 20 additional laps. So use the mathematical representations given in the task with the table and the graph to model the equation you wrote in question 4. Write down words to explain the new function to your class. So what we're basically saying is Fernando's equation or function is the same as Mariah's, except his is translated 20 units up. So they're the same thing. Fernando's is equal to Mariah's, except Fernando's is translated 20 units up, which is represented with the plus 20. All right, so let's move on to the lesson now. So what we're doing is we're training part 2. Fernando and Mariah continue their training in preparation to the half marathon for the remaining weeks of training. They each separately kept track of the distance they ran during the week. Since they ran together at the same rate same rate on Saturday, they took turns keeping track of the distance they ran and the time it took. So they would both keep track of their own information. The other person would use the data to determine their own total distance for the week. Mariah had completed 15 more laps than Fernando before they trained on Saturday. Complete the table for Mariah. So here we go. We still have the same. Oopsie. So it says Mariah completed 15 more laps than Fernando. But remember, on Saturday, they run the same amount. So before Saturday, so before they start running, Mariah ran 15 more laps more than Fernando, which means this would be 65. And then together, they run the same amount of laps. So Fernando, from 0 to 10 minutes, ran 6 laps, which means since they're running together, Mariah also completed 6 laps to get to 71. And if we continue to add 6, we would get 77, 83, 89, 95, and 101. Now, if we want to write an equation for Mariah that transforms Fernando's equation for Mariah's, this would be Mariah distance is equal to Fernando's distance plus plus 15. That 15 represents the additional 15 units that Mariah ran during the week. So now, on Saturday morning, before they started running, Fernando saw Mariah's table and stated, "My equation this week is f of t equals m of t plus 30. This is stating that Fernando ran 30 more laps than Mariah. So over here, if we look at the laps, Fernando will be running 30 more before they begin. So that means that he started off running 75, my apologies, 75. Now they run together, so every 20 minutes they will every 5 minutes they run 3 laps. Every 10 they'll run 6, which means every 20 they will run 12. So we're basically adding 12 here. So 75 plus 12 is 87. 87 plus 12 is 99. And then we have 111. And then 111 plus 12 is 123. All right, so then from there, make sure I got that right with my mental math in my head. Okay, so then from there, guys, what we are going to do is write an equation for both runners. And so when we look at this, well, the first equation we can do m of t. M of t is equal to 3/5 t plus 45. Now I'm unsure if they want us to have this as built on Mariah or independently. So if it was independently, f of t would equal 3/5 t plus 75. Or for 100% acceptable, we could have put f of t is equal to m of t plus 30. Now, I guess technically we could have done m of t equals f of t minus 30 as well. So let's go ahead then and look at this. So over here then it says, sorry, I keep messing up on my question over here. I'm just double checking something. So write the equation Oh, okay. So I kept looking up here thinking, what is wrong with my numbers? It's not matching. See how I go up by 20, up by 20, up by 20, and then up by 10? So I kept thinking, what am I doing wrong up here? So instead of adding 12 to 12 to 12, I should have added, instead of 12, I should have added 6, which would have given me 117. So sorry, I couldn't figure out what I was doing wrong back there, but now I found it out. So now what we're going to be doing is write an equation for Mariah transformed from Fernando. So we're trying to get Mariah, m of t, but we're going to incorporate Fernando. So that would just be f of t, and since she ran less, we would be minusing 30 from it. That's how I would get from 75 to 45, 87 to 57, 99 to 69, so on and so forth. Now, what relationship do you notice from your answer in part C and D? And essentially what it is, whether we're starting with Mariah or we're starting with Fernando, what we can do is we can manipulate either equation. So we build off the other person to create a So we can manipulate either equation, so we build off the other person to create a function built off the other. So for instance, it doesn't matter, you could write m of t or f of t equals, but then we would just have to manipulate the equation so it represents the table or graph above. So now what we're going to do, it says use Mariah's graph to sketch f of t. F of t is equal to m of t minus 10. So remember what this is saying is Fernando, the amount he ran is equal to Mariah, but his is 10 less. So instead of starting off at 40, Fernando started off at 10. If I look for another integer right here, so right here we would go down 10 units. And then when I go ahead and draw this, oopsie doopsie, I would draw this line, and this line would be parallel. So let's go ahead, once again, write the function for both people. Well, the first one for Mariah, hers would be m of t is equal to 3/5 t, so that's what they're running together, plus 40. And then Fernando would be f of t is equal to 3/5 t plus 30. Let's see. Now it didn't say anything about building it off, and since I already built off f of t is equal to Mariah's minus 10, I guess technically we wanted to, since it doesn't specify, we could have m of t is equal to f of t plus 10. So that would also be an acceptable answer. Now when it asks us, it says, what do you notice about the two graphs? Would this always be true if one person ran k laps more or less each week? So when we look at this, if two people are running together, which they have been here, would the two graphs always look like this, meaning be parallel? And for the most part, I would say yes. If the two people are running together on Saturday and therefore having the same slope, then the two lines will be parallel, knowing, or I would say given, they did not run the same amount of laps during the week. And then we can even put, like, this would be like the exception. That would mean they would have ran the same laps. Means it would be the same exact line. So if they both run 30 laps during the week, and then they both run together, their lines would be right on top of each other. Therefore, not parallel. They would be the same line. So this is the last week of training together. Next Saturday is the big day. When they arrived to train, they noticed they had both ran 60 laps during the week. Write an equation for Mariah, given that they run at the same speed they have every week. So then what we would have is m of t is equal to 3/5 t plus 60. They run together on Saturday, and they ran 60 laps during the week. So write Fernando's equation as a transformation of Mariah's equation. All right, well, I know that Mariah has ran the same amount as Fernando. And there we go. So what conjecture can you make about the general statement g of x is equal to f of x plus k when it comes to linear functions? So if we're looking at two linear functions and g of x is the same as f of x, the difference is that f of x either goes up k units or down k units. We would determine that the two functions are parallel. The two functions are parallel. F of x is translated either up or down k units. All right, guys, that's the lesson for today. So then right now you guys can start module RSG 7.2. When you're all done with 7.2, you may start homework in another class. You guys are awesome. I'll see you guys later.